The diagram shows a transport or flow network, a system of nodes connected by directed edges, each with a maximum amount of flow it can carry. On the far left is the source, labeled as S, where all flow begins. On the far right is the sink, the point where all flow must end. The purpose of a maximum flow problem is to determine the greatest amount of flow that can move from the source to the sink without violating any capacity limits. Between the source and the sinks are several intermediate nodes arranged in the three rows. They are connected by arrows which represent and allow the direction of flow movement. Flow can travel only in the direction of arrow points. Each arrow has a number beside it representing its capacity, meaning the maximum flow that edge can carry. For example, if an edge has capacity of 7, it can carry more than 7 units of flow. There are multiple possible paths from the source to sink. Flow may travel upward, downward, or straight across as long as it follows the directed edges. Some edges move flow from left to middle nodes, then on the right others nodes vertically or diagonally, allowing the flow to shift between different routes. The picture illustrates how flow can split or merge and reroute depending on available capacity. Some edges have high capacities and can carry large amounts of flow, while others have a small capacities and can create bottlenecks. A bottleneck is an edge whose limited capacity restricts the total flow along a path. The main goal is studying such a diagram is to determine the maximum possible flow from S to the sink, given all capacities and route options. To do this, we consider how flow can be distributed across different paths and where tight capacity constraints appear. In summary, the diagram is a map of all potential routes from the source to the sink, each labeled with how much flow it can hold. Understanding the nodes, arrows, and capacity and allow us to analyze the total flow of the entire system that can support. Thank you.